All right. So, is there any question? Do you have any question about your exam, about the things we did before, about anything you want to ask? Is there any question? Okay. If you don't have questions, let's go forward. If statement. So, the last time we discussed logical expressions, and we said that with logical expressions, we get some result. We also said that in other programming languages, we get the result of logical expressions as Boolean. But in the C programming language, we do not have a Boolean type. So because we don't have a Boolean type, it's not possible to get a Boolean outcome. And so we said we get 0 or 1, where 0 means false and 1 means true. So the idea is that we pass this output 0 or 1 into some expression that requires a conditional output, or let's say an expression that requires a conditional input. So last time I remember I drew for you the truth table, and in the truth table we have a representation of values for all the possible combinations of input for and, or, and not. Maybe we start from there. Maybe we refresh ourselves with that, and then we move to today's work. So last time I said we can have um, x, we can have y, we can have x and y, we can have x or y, and then we can have not x, we can have not y. So we add something like this and we try to separate them. All right. So we said for x, we could have 0, 0, 1, and 1. And here we would have 0, 1, 0, 1. And so we said the combination of x and y, we said the only time that this is true is when both of them are true. The only time it is true is when both of them are true. So we said this is the only time it is true. This is the only time it is true. Now for or, it's the opposite. We say the only time this is false is when both of them are false. The only time this is false is when both of them are false. So from this point, everything is the opposite. Everything is the opposite. So 0, 0, 0. This is opposite. 1, 1, 1. All right. If that makes sense, then it seems we can proceed. Now for not x. For not, we said that this not means negation. We discussed that in our slide. So we said um, okay, we said it is negation. We said not expression will have a result 1 if expression was 0. So if expression is 0, it will have a result of 1. And it's going to be the opposite for opposite values. If expression was 1, then it will have a result 0. So, all right. Okay, so let's continue with our explanation. So Now we are looking at x for not x. X is 0, so the output is going to be 1. X is 0, the output is going to be 1. X is 1, the output will be 0. X is 1, the output is going to be not 1, which is 0. And for this is the opposite of y. Y is 0, the output must be 1. Y is 1, the output must be 0. Y is 0, the output must be 1. Y is 1, the output must be 0. So this is what we call the truth table. This is the truth table for basic Boolean values. This is the truth table. Okay. Um, let's make it big. Maybe bigger. All right. Okay. So that's the truth table. So now here is what we are trying to say. We are trying to say that we can build with this kind of combinations with just maybe not x, which maybe just not y, with x and y. Since we know the input of x, we know the input of y. With this, we can build expressions that will provide values. And why would we build these expressions? Because we have other expressions that would make use of the result of the logical expressions. And that is where we will start from today. We will start from the if statement. The if statement relies on the output of a logical expression. The if statement allows a program to choose between two alternatives by testing an expression. So in its simplest form, the if statement has the form of if, expression, and then statement. This order is really important. It is if, an expression, and then statement. If you observe, it is statement, not statements. And this is really critical for the use of if expression. And in not a number of other statements, I mean, as we continue, you will observe. Okay, so when an if statement is executed, expression is evaluated. If the value of the expression is non-zero, if the value of the expression, this expression in this example, if the value of this is non-zero, then we consider it to be true. And so we evaluate the body of the if. This is just the idea. We evaluate the body of the if. Okay. Now, I remember I told you earlier that this is not assignment. This is assignment. And that this is equality. Two equal signs mean equality. So if you want to check if x is equal to y, then you use these two values. Um, just a minute. Okay, so the statement if I is equal to 0 does not assign 0 to I. This is important. It's not assigning 0 to I. It is checking if the value in I is the same thing as 0. So the statement if I is equal to 0 is completely different. Observe this as one assignment operator. This has two assignment operators. Two assignment operators become equality operator. So here we are checking if the two of them are equal. Here we are just evaluating the value of I. Actually, this is what is going to happen. It takes 0, puts it inside of I. That is the first thing that happens. So it solves the assignment operation, puts 0 inside of I, and now it checks if what is the value of I. Since the value of I is 0, as far as C is concerned, it means false. So if what you wrote here was I is equal to 7, it would have been something else. Because by saying I is equal to 7, it would put 7 inside of I, and by after putting 7 inside of I, it checks the value of I. I would be 7, and 7 is not 0. 7 is true. 0 is false. 1, 2, 3, any other thing that is not 0 is considered to be true. So it assigns 0 to I and then tests whether the result is non-zero. Now, since the result is 0, this expression would mean false. All right. Often, the expression in an if statement will test whether a variable falls within a range of values. So some other time we want to check if a variable falls within a specified range of values. So if you take a look at this example, it's similar to something we did earlier. We did this something close to this at the beginning of this chapter. So what are we doing? We are saying if 0 is less than or equal to I and I is less than n, then do something. By the way, we saw it in the paint. This is and. This means and. Same thing we have here, and. So if 0 is less or equal to I, we check that. So we check what is the value of I. Let's assume I is 4. Is 0 less than or equal to 4? Yes, that's true. So we wait and we come and check this place again. What is n? I is 4. Is 4 less than n? If the answer is yes, then the answer of this expression is yes, which is 1. To test the opposite condition, that is I is not within this range, then we say is I less than 0 or I is greater or equal to n. Observe here, we are saying less than n. We are not including n. So the opposite will include n. Greater or less than n. Now, compound statement. Uh, Please, I want you to be focused here because I guess this place can get some students confused. Now, if you go back to the example of the if expression I showed to you at the beginning of this context, let me go take you back there. Here is it. I said if the expression, now you are familiar with the expression, it's anything that appears to be a logical test. After the expression, we have a statement. And I remember I told you that it is statement, not statements. But this becomes a problem because many times we want to write more than one line. So, how could we write more than one line when the policy of the programming language says statement, not statements? And that is where compound expression becomes important. Compound statements. So, we use compound statements to solve this problem. Instead, instead of getting stuck and being unable to solve multiple lines in a loop or in an if statement selection, we make use of an alternative called the compound statement. The compound statement helps us to group many statements and make them form one statement that if requires. If requires just one statement after the test expression, there is nothing we can do to it. It expects only one statement. But to solve this problem, C also has a structure called what's the name? Called blocks. So this the group of code that we put within this curly braces is called a block. So if you put code inside of this brace, all the code will be considered as one statement for the if expression. And this is the solution we have for writing more than one line. Okay, I just installed the devs C++ compiler. Let's see if we can try some experiment. Okay, so we say I I is equal to 0, or let me just change them. X is equal to 7. So I can say if I is less than 4, print, yeah. Okay, this is something. The code is basic. I guess you understand this. But in case anybody doesn't understand anything, I can answer your questions. Is there anything you don't understand here? Omar or Nur, Tankut, do you understand everything? Okay, I hope so. Right, that's good. So let's run our code. Um, let's save in documents. It's going to be C code, and then we can say tests for selection. Okay. Yep. So it says, yeah. What did we do? We set the value of I to be 0. If 0 is less than 4, print yeah. But if we have more, it won't print because it needs just one line. So to solve this, we make use of compound statement. So let's try to expand it. Now, if we try to execute this, it gives us an expected result. It says, yeah, it's less than 4. But let's see some other thing. Let's put this to be 0. I is 0. Is I less than 0? No, I is equal to 0. So the expression here would be false. And so we should not be able to enter into the if statement. But you will see that it would print line 8 because line 8 is not part of the if statement. It expects only one statement. See, it's printed, it is less than 4, even though it didn't print here. Why? Because here is the only part that is connected to the if statement. Line 8 is just part of the main program. So how do we solve this? We solve it by making use of the block idea. So we put the piece of code inside of the block and we execute. This way, nothing will execute since these two lines are part of this body. When this body evaluates, the answer is going to be false. And that will be all. Nothing evaluates. If we change it back to 4, then everything evaluates. Okay. So I hope you can refresh this. So let's continue with our discussion. So to make an if statement control two or more statements, we make use of a compound statement. The compound statement has the form of many statements in curly braces. Putting braces around a group of statements force the compiler to treat them as if it's just one statement. So here's an example. We have all of these together on the same line. Why? Because we don't care. We can put semicolon, as semicolon already tells the compiler that we have come to the end of this idea. So after this semicolon, anything it sees here should be considered as a new idea. So we can put everything on a single line. A compound statement is usually put on multiple lines with one statement per line. I mean, it's what you like. Mm. Each inner statement still ends with its own semicolon, but the compound statement itself does not have a semicolon. The compound block itself does not have semicolon. So what it means is inside of this if, you can have another if. So the lines of that if will have its own semicolon, but the compound statement itself will not have semicolon. So we can do something like this. We can say if I is less than 4, and then we get into the body of this. I can say again if x is greater than I. Okay, so this is just one line. Observe this if statement belongs to this if. It is inside of this if. This if statement expects also one statement, and I have given it one statement. Okay, let's go. What do we have? It says I is a very special number. Why? Because I is 0 and 0 is less than 4, and at the same time 7 is greater than 0. 7 is greater than 0. So it displays what normally we expect it to display. I is a very special number. So for the case of I, if we want to put other expressions, other statements, it's going to be with the same idea. Any other thing I put like this without the block will not be part of the if x is greater than I. It's going to be part of if I is less than 4. So I say print f still in x greater than I. So this line, as as it stands now, is not part of this if statement. This line is part of this if. So even if x is not greater than I, okay, let's say x is 0. So now is 0 greater than I? Because I is 0, 0 is not greater than 0. So we know that this expression is false. So it would not print this part. But because there is an extra line to the highs, it looks like it is part of this if. But based on the policy of the C programming language, we know it is not part of it. So this line will still print, even though this one will not print. Just like in our previous example. Can you see? It still displays still in xi after this place. All right, let's move this to a new line so that things are easier to identify. All right, can you see? It prints this, but because the condition here is false, so it skips this, but it sees this guy as part of the previous statement. So it still prints still in xi. So please, I need you to keep this in your mind that the C programming language is very sensitive to this. It's very sensitive to the display, the grouping of the body of compound statements, as it were. Okay, so here is it. Now it's gone. Okay, so this is an example of a compound statement. If this is that, okay, all of these are pretty simple expressions. Now that you understand the general policy, I always use, okay, you always use the brace after if. It's correct, it's correct. If you have just one line and you use it, it's safe. It prevents you from making mistake. So it's correct. If you if you are always trying to be careful to not use it when you don't need it, then the day you need it, you may make a mistake of forgetting. But if you always use it, it's fine. Now, an if statement may have an else clause. That means if you don't do this, do something else. An if statement may have an else clause. That means if expression, do something, else do another thing. And here is an example of that. Here we say if I is greater than j, then we know that between I and j, I is the maximum. If I is greater than j, we know that I is the maximum. But we can say else, then j is the maximum. So this is common sense. Let's try. Let's use I is equal to 4, and then we change our code. We can say if I is greater than x, what do we do? Then we say max. All right, let's introduce the variable max to our programming environment. Max. All right. So we can say max is equal to I, else max is equal to x. Printf. Finally, our max is um our max is, let's leave a space, max. Okay, I hope this makes sense to you. Does this make sense? Do you understand everything? Okay, please, just a minute. Just a Okay, I'm back. Sorry. So, what are we doing? We have set the value of I to be 4. I is an integer, x is 7, x is an integer, and then a variable called max. Max, we don't know the value of max now. It's undefined. So we go down to check if I is greater than x, then I is going to be the maximum. But unfortunately, I is not greater than x because we know in mathematics 4 is not greater than 7. So this expression will be false, which is 0, and this expression, this statement will not be evaluated. So we come to the else part of the if. The else part just says, okay, if this guy is false, then just believe that I am true. That's the meaning of else. So if this guy is false, then I am the true one. If the if statement before me is false, I am true. So if I is not maximum, then since we have only two things, then x is maximum. And so we have a statement, our max is this and that. All right. So let's run our code. So it says finally our max is 7. So our max is 7, between 4 and 7. So let's change the value of I to, let's say, 42. If we evaluate our program, our max will change. Our max will become 42. All right. So let's go back to our slide. When an if statement contains an else, where should the else be placed? Many C programmers align it with the if at the beginning of the statement. Inner statements are usually indented, but if they are short, they can be put on the same line as the if and the else statement. Okay, here is what it's saying, that where do we put this else? It is sensible to put the else in the straight line with the if, just like the compiler has put the line. Then it says that, how about the body of the code? Where should we put it? Okay, it is one line. You can leave it here, but if you want, you can put it here. It does not matter. It will work. If you want, you can put it right in front here. And this is because it is just one line. I mean, you can do this. If it is more than one line and you still want to put it here, no problem. As long as it can fit, you must put curly braces there, and then you fit everything inside of the curly braces. So if we run our code like this, everything will still work well. So everything is still working well. It's not unusual for if statements to be nested inside other if statements. Okay, this is not new to you. I already demonstrated it to you in the previous example. That inside of the if, we can have another if and its own else. And this if has its else and something like this. Um, okay, but to avoid confusion, it's best you put curly braces here and here so that you group this code as a body of this if. But here is the general idea in most programming languages. If you have this if and you have an else here, you have this if, you have an else here, this else belongs to this if, even if you don't put parentheses. This else belongs to this if. But let's look at a situation where we don't need else for this situation. Let's assume we don't need else. Um, Probably I should copy this and paste in the compiler. Maybe it would be easier to explain that way. Okay. If I is greater than j, then we enter and um okay. So this else, from what we did, we are trying to make sure that this else belongs to this. This if is here. Mm-mm. Okay, so I guess you understand what is going on. Maybe down here we may like to print um, marks is okay. We want to print this. So what is happening? Let's look at our code. We will set some values for I and j. Let's say int I is equal to 8, j is equal to 11. All right. So we can run our code now. Our code evaluates the value of I and j. It says if I is greater than j, okay, we will still need k. K is equal to 10. Nice. So if I is greater than j, is I greater than j? No. So this expression is already false. Because it is false, we just come straight to this else. And in this else, we check if j is greater than k. Is j greater than k? Yes. So that means the maximum of everything we have is j. J is 11, so j is the maximum. But if j was not greater than k, and we already got to this situation, then we know that k is the maximum. All right, let's run the code. What is going on? Max. Oh, I didn't prepare the max variable. Okay, so it says max is 11. This is very clear. It makes sense. Max is 11. Okay, now here is what I want you to think about. If I remove this else, what would happen? Okay, let's first change the situation. Let's make I to be 18 so that we can test in a different way. Okay, we know that I is the maximum now. Let's not make I the maximum. Let's make somebody else maximum. So if I is greater than J, is I greater than J? Yes. So we come here and then we check the remaining situation. Is I greater than K? No, I is not greater than K. So we come here and we set K as maximum. Okay, so max is still 19. Max is K. So we do that from here. Now, here is what I want you to observe. In case I don't need this part. So it means um, if I is greater than K, I is not greater than K. So we come here and then we check if J is greater than K, which is false, we come here. And so we say max is equal to K. Okay, I'm trying to find a case that would make it easy to understand what is going on. I'm trying to think logically about it, but it's eluding me how to explain this. Here is what I'm just trying to make you understand that this if, even though it's on this same line, it does not belong to this if. This if belongs to this if. This else belongs to this if. Why? Because based on the rule in C, else belongs to the nearest if. Every else belongs to the nearest if. And because of that, this else does not belong to this if. This else belongs to this if. So if we want to avoid it, we have to put this marks in compound statement. By putting this marks in compound statement, we have to put this expression in compound statement. So by putting from the if to the max in compound statement, this entire part belongs to this if. And so since it is closing here, it can't claim the else anymore. So the else belongs to this if. Okay. Any question? Any question? None. Okay. To avoid confusion, make sure you add parentheses. Use as many braces as possible, just like um you were asking just now. It's better to use braces, just like Omar asked. Advantages of using braces even when they are not required. It makes your program easy to modify because visually you can identify the location of each part and you can identify the end of each block of code, each part of code. It helps to avoid errors that can result from forgetting to use braces. Cascaded if. Cascaded if. So with cascaded if, we have if inside of if. So a cascaded if statement is often the best way to test a series of conditions, stopping as soon as one of them is true. So we can say if n is less than 0, else if n is equal to 0, print n is equal. But if else is not less than 0, actually it can be two things. It can be greater than 0 or equal to 0. So we have checked for equality here. Then the next must be greater than 0. So this is what we call cascaded if. From one, we get an else. From that else, we have another if. From there, we have another if. And so we continue that way. Although the second if statement is nested inside the first, programmers usually don't indent it. Instead, they align each else with its original if. So instead of putting if in an indent, it is down here, but normally you can just put it in front like this, and only the else stays without an if. This layout avoids the problem of excessive indentation when the number of tests is large. Okay, here is the explanation. Now we have else, we have an if. Observe, we already have one indent. In case we have a lot of ifs, if we have like 50 if conditions, before you get to 50, remember that with this if, you already move one indent. You'd have moved another indent, another indent, another indent. Your code would look diagonal like this. And after some time, it will be really difficult to scroll down to read your code. You have to scroll even horizontally also. So because of that, programmers don't do that. They simply bring the if to the front of the else. They bring the if up to the front of the else. So this layout avoids excessive too much indentation if you have many cases to test. So here's an example. Calculating the broker's commission. Let's have 10 minutes break. We come back and then we calculate the broker's commission. Okay, so we want to evaluate the example of a stockbroker. When stocks are sold or purchased through a broker, the broker gets commission. So the commission depends on how much of stock that was traded. So let's assume the stockbroker does this commission. If you sell or buy below 2,500, there's a fixed amount, $30, then plus 1.7% of 2,500. If it is above 2,499 uh, and it's less than 6,250, then there's a fixed amount of $56 plus 0.66% of what amount it is in this range. So we have this like this. And under no circumstance would the stockbroker charge less than $39. So if we have a situation where somebody bought, let's say, $1,000, $1,000 would incur $30 plus 1.7% of $1,000. And 1.7% of $1,000 would not make it up to 39. So this would not be allowed. 1.7% of $1,000. Let's okay. Actually, I think it's higher. Let's just say something like $5 is the 1.7% of what the person buys and it ends at $35, the stockbroker would not accept $35. He will accept a minimum of 39. So you have to write a condition in your code that if the value the stockbroker is getting is less than 39, then we should change it to 39. All right. So this is what we have here. The stockbroker.c program asks the user to it asks the user to enter the amount they want to trade, and so it shows the commission. The heart of the program is a lot of if and else statements, because here we will say if the value is less than 2005, then do something. Else, if it is less than 6,000, we then do something. So we have a lot of if and if and if and else. All right. So here is the code. Let's start by copying it. Let's see if we can. Okay. Yep. Okay. So this is the stockbroker's code. It asks for a value to trade. It accepts the value, stores it inside float value, prepares a variable to calculate commission. So if the value the person wants to buy or sell is less than 2,500, then we calculate a commission based on multiplying 0.17 times that value. After getting that, we add it to $30, which is a fixed amount. We do it for all the possible amounts the person would buy. But remember that there would be a time where 30 plus 0.7 f of value would be less than 39. So we must watch for that. We are going to say if there's ever a time that commission is less than 39, then forget about that commission amount and change it to 39. So at this time, we can now print whatever commission that we have calculated. Let's run the code. Okay, so it says enter the value you want to trade. Let's say the person wants to trade $700. $700. This probably would be less than 39, so the code does some computation. Oh, $700 is good. It's above 39. Um, Maybe we can say put a print statement here and say commission before adjustment is equal to um where is dollar percentage dot to f commission. And by the way, we should move to the next line. All right. So we can say 300. So commission before adjustment is 35.10, but after adjustment, we returned it back to 39. So here we can catch. Oh, I didn't put on the screen. I'm sorry. So commission before adjustment is 35. After adjusting, it becomes 39. So with this way, we are very sure that the stockbroker would not earn less than 39. The dangling else. Okay, we discussed this already. The dangling else. When we have cascaded if and else, Whenever an internal if, whenever the if that is inside does not have an else, but the if that is outside has an else, how will the compiler associate this else? Who will the compiler give this else to? Will it give to this if or will give it to this if? So this is the meaning of dangling else. The else that does not have a home is dangling. Well, as I already told you, the answer is simple. The answer is every else belongs to the nearest if that does not have an else. Normally, so this else belongs to this if. So, however, C follows the rule that else clause belongs to the nearest if. The nearest if statement that hasn't already been paired with an else. So the nearest if that does not have an else is this, nearest to the else. So we associate this else with the if. So in case you don't want this else to belong to this if, we already established that you use curly braces. A correctly indented version would look like this. So if you use indent, you put this indent for this, you put this indent for this, but I'd observed at the same time, this else is here. So in any case, if you indent it, you don't indent it, it does not matter to the C compiler. Even if you leave it like this, it does not matter. This else belongs to this if. Okay. If you want to make the else to be part of this previous one, then you must make sure that you group everything here to be part of this if. And since what is in this block cannot own the else that is outside, so clearly this else will belong to this if. So we have an operator in C called the conditional operator. It is used for if. Normally you can say something like this. Um, okay, let's just go this way. We can say if value is greater than 0, um, commission is equal to value. So let's just use this as example. Else if value is equal to 0, then commission is equal to value, and then we can say else um commission is equal to value. Let's say if it is now greater than 0 plus 1, value plus 0, value minus 1. Okay, so we can come down and make a print statement. Okay, so we can do something like this. We can receive a value from the keyboard, and then let's just change everything to integer. There's no point using float. Okay, so we check if the value is greater than 0, and so we subtract 1 from it. If the value is equal to 0, we do nothing. If the value is less than 0, we had 1. All right. We can have such a situation, but there's a simple way to have an expression like this. we can make use of the conditional operator. Also, we call this the ternary operator. So what this means is we have an expression here followed by a question mark, another expression followed by a semicolon, a full colon, and then a third expression. So these two expressions must be fixed expressions, must be expressions with values that can be calculated. This usually is a variable. I mean, okay, this okay, actually everything can be expressions, but we can just assign to a variable. So here is what it means. So for this situation, if we run our code, we get something like this. Enter the value. Let's say the value is now 8. So we subtract 1, it becomes 7. All right. But for the ternary operation, we can say um, I remove this. Commission is equal to actually I need this guy. Yes. So we can say if the value is greater than 0, then we have value plus 1. Else, we can have value, let's say minus 1. So this is the implication. So we get the value, we check, is the value greater than 0? If the value is greater than 0, we add 1 to it and we store it inside commission. If it is not greater than 0, we subtract 1 from it and we store inside commission. This is called the conditional operator, also called or the ternary operator. So it's asking for the value to trade. We can say 6 again as usual, or 7 as the previous example. Now it is 8. So it says, is it greater than 0? If it is greater than 0, we add 1. If it is less than 0, we subtract 1. Okay, I think the logic should be the opposite based on our last example. So this, yes. So this is the ternary operator. If we put 7, because it's a positive value, we subtract 1 from it. If it is a negative value, we add 1 to it. So let's say it's 0, it adds 1 to it. So this is called the ternary operator or conditional operator. The operands can be of any type. The resulting expression is said to be a conditional expression. All right, I think probably we should stop here. Let me see what's the next thing. Conditional expressions. Okay, the logic is the same. Maybe I just read this and then we end. The conditional operator requires 3 operands. Because it requires 3 operands, we call it the ternary operator. If you remember, the negation operator requires 1 operand. We call that the unary operator. The plus, minus, multiplication require 2 operands. We call them the binary operator. So because this guy requires 3 operands, we call it the ternary operator. Okay, the expression is evaluated in stages. Expression 1 is evaluated first. If it is true, we evaluate expression 2. If its value is not 0, that means it is true. Then we evaluate the second part, expression 2. But if the value is 0, we evaluate expression 3. Okay, so I already demonstrated for you. You don't essentially need explanation on this. So we have three variables I, j, k. I is equal to 1, j is equal to 2. Is I greater than j? Then we say I is the greatest, else j is the greatest. So it's easy to make some evaluations based on the ternary operator. They tend to make programs shorter, but sometimes they could be hard to understand. So it's interesting to use, but if you find it difficult, why not? You may avoid it. But if I ask of it in examination, you cannot avoid it. Conditional expressions are often used in return statements. So you can return the output of this expression. It's pretty basic. You can assign it to a variable and return the variable, or you can return the result of the expression directly. It doesn't make much difference. Sometimes we can use it in printf. We can say, okay, evaluate this value, and whatever is the value becomes the result of this entire expression. And that would be the integer to be printed. Okay, so we stop here. Next time we start from the switch statement. Any question? Does anybody have a question? No question. All right. So please write present in the chat so I can be certain that you three are still available. Please write present in the chat, except if you are asleep. Write present in the chat. Remember, we have just 1 minute to end the class. So please write present in the chat. I'll wait till 10:50 and I'll stop the class.